record. And we're recording. Here we go. So this is problem number dos. Problem number dos. Okay. I think you guys forgot how to do these, even though they're not that difficult. I want to be able to kind of look them over and kind of solve them out. One thing that we got to be able to do here and use is Sohcahtoa. Sohcahtoa is the acronym that we get that we can use to help us solve and determine which trig ratio we can use. Okay. Now what we want to do with this, what's our first step when doing these type of problems?
Label them.
Label them. So x is going to be equal to what?
X is going to be equal to
O. This little arrow right here tells us it points in the direction of the hypotenuse, which we have nada. And then our 35 will be equal to A. So what part do we not have any information on? So we cross out everything with so and ka get canceled out. That leaves us with Toa. So setting this up, we get tangent of the angle, which is 51, tis equal to our ratio opposite x over 35. Is this starting to ring a bell? Ring a ding a ding ding dong. Let's check out. We always try to simplify this out so we don't get confused on these numbers. Tangent of 51 is 2, 3. What do I do from this point? Cross multiply. We're going to get x. I'm going to kind of eliminate a lot of my work here. Not really show a lot of it. I'm just going to kind of show the answers and not really the multiplication and stuff. So my apologies, but I want to get through problems. 0.05. Compendos. Remember them? Cool. Sohcahtoa, that's what we got to do. Do the do, man. Do the do. Questions? Writing right next to it. 3 or 4? 4. Heard 4. I'm going to try to draw accurately for you guys. Look at those straight lines. I know, so proud of myself. We're going to get 15 for the hypotenuse. I'm good. Promise. We still got to use Sohcahtoa. Suck my toe. You guys do fun. Here we go. So we got to be able to label what's my reference angle here, right? It's going to be our x here, so I want to be able to use that as my reference angle. That means I got to label everything from that. The arrow, this little bad boy, tells us what direction the hypotenuse is, which is going to be our 15. The opposite side has no information. It is blanked. We are confuzzled. That means we have adjacent on the top. So which ones am I going to be crossing out? Oh, I'm a magician. So and Toa. Go away. So we are going to use ka, bro. Ka. Come on, ka. Come on, ka. Ka will be cosine of my angle x will be equal to our opposite, or sorry, adjacent, 14 over 15. Now, can we use cosine of x? No. That means we got to do what?
Negative
Cosine inverse of the fraction.
14
Over 15. Did someone do it for me? And how do we get there? We hit shift.
And then you get 21.
I'm going to make sure so I don't mark this down wrong. And we're going to get 21.039 something, but we don't. I just want you to copy what's there. You don't need a round. Do not round, my children. Do not round. Cool stuff? Cool beans? Cool story, bro? Yeah? Okay. Those are how you do them. So those first 4 should be pretty fast, yeah? Yeah. 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 Here we go. Cinco. de Mayo. Cinco de Mayo. Oh, 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 oh. ACB. It's an ACB. Now, Sohcahtoa again. Sohcahtoa. Noah. Cool story, bro. Now, in this case, we had several problems. In this problem, it said solve for A, said solve for AC. We're just going to say solve for the length of AC. So let's just give it a variable so I can put context to it. Let's give it X. So we'll give it context. It helps us out a little bit more. You can also label this as AC as well, just the length of AC. It's just a variable. That's how we want to define it. If we're solving for this, we're going to use our reference angle at 50. This tells me my 50, this X is going to be the opposite. The 15 is going to be the hypotenuse. The CB is going to be the adjacent, which has no information. So what do we use? Which one does not have any information?
A, so that means you don't use
Sohcahtoa. So sine, we got to use sine. So sine of my angle 50 is equal to the opposite over hypotenuse. We're going to use this as a fraction. I'm going to rewrite this as sine of 50. So we're just going to estimate it. It's an approximation for you YouTubers. Because I'll get people like, you didn't use the correct one. We're just approximating. Chill out. When we simplify this out and we do cross multiplication, we're going to get X is equal to whatever 15 times 11.4. So that's what we got to be able to do with this one. The second one is essentially doing the same thing now. The second one is doing the same thing. So I'm going to kind of erase a little bit of this. Or let's just draw the same one. I'm just going to draw a smaller version of this. Okay, we know X to be, or this, I don't even need to draw that. Let's just say I was going to draw it without it. Sorry, I'm kind of rambling. Okay, this is the same picture. If you want to draw it, you do not have to. In our bottom side, if we're solving for, so this bottom side tells me for BC or CB. In this case, let's just label this Y. So now we're solving for Y in the context of this problem. So you can break them up into each part. We're going to go ahead and use 50 as our reference angle again. That means opposite has nothing. Hypotenuse has 15. And our adjacent is going to be our Y. So using Sohcahtoa again. In the context of the problem, what are we going to eliminate? Everything with an O. So Toa and So get away, leaving us with cosine. So cosine of our angle of 50 will be equal to our adjacent, which is Y over 15. So again, this one kind of looks out nice. Ice is nice. We're going to kind of simplify this out. Cosine of 50 is going to be 0.64 over 1. Y is equal to 15. Y is equal to 0.64 times 15. Do not trust you guys anymore. You have led me astray. So those are the two lengths that we can solve out for, so we can continually do this. I'm going to go ahead and eliminate this top part just so I can draw on my last one. The part C to this, part C was actually finding what angle A is equal to. Find angle A. What do we know about the sum of the angles of a triangle? 180. They add up to 180. So it'd be pretty much angle A plus angle B plus angle C is equal to 180, sorry. If we plug in for what B is 50, C is 90, and we solved out for angle A, we're going to get 40. Done. Does this help going over these problems? Yeah. I'm hoping, man. I'm hoping. Cool story, bro? Cha, bro? Cha. Cha. Here we go. That was 5. Do I need to do 6? See? No? We get it?
Yeah.
Okay, do you want me to do 6?
Yeah, do it.
6. 7 is very similar to 5, so I'll skip over 5. Cool? Cool. So I'm going to clear it. You might want to clear it too. That means don't erase right below. Let's do the do. My artistic abilities right here. Look at those perfect lines. Like a champ. 17. Angle. Right angle. B. C. Ooh. This one's asking us for several different things. This is asking us for BC. So length of BC, measure of angle A, and the measure of angle B. So these are the 3 that they're asking us for. Now, in the context of this problem, it doesn't give us really any other sides. It doesn't give us the angles. We don't know what A and B are. But the good thing about it is using trigonometry, let's say that this is our reference angle. Let's say that this is X. We can solve out for what X is by using trig ratios. So let's say we're solving out for our blue one first over here. And we're just going to label this. According to our sides, this is our hypotenuse and this is our adjacent. Okay, our opposite would be our O here. So using Sohcahtoa, which 2 would we have to eliminate? So I'll just write it down below. Sohcahtoa. Which ones are we getting rid of? Everything with what? O, right? So and total get eliminated because we don't have any information. This leaves with the cosine. But when we use to find the angle, we're going to use the inverse. So cosine inverse of the adjacent over hypotenuse. What's our adjacent over hypotenuse? 8 over 17. So whenever finding an angle, we use the inverse ratios. And if you were to plug those bad boys in, what do we get? I prefer you guys try it just so you guys can get used to it. It's going to be 61.9. Now these are approximations. This is why when you subtract it from 90 and 2807, it's not going to give you perfectly 180. But this is just as similar. If we want to solve out for B, we can do that just by adding up 90 and 169 to subtract it for B. But if just to practice this again and just using another reference angle, if I were to draw this one out again, this is part B. We're getting 8 and 17, A, C, and B. We can actually do the same kind of setup again. And this is where I got that same thing. Sohcahtoa to solve for this angle now. Let's just say that this angle now was Y. Right? They're 2 different angles, so we can label that as our reference angle for Y. And now set up the same thing. 17 is still the hypotenuse. 8 is now the opposite. We don't have anything for the adjacent. So if there's nothing for the adjacent, we get cut and toe eliminated because we do not have any information on those. And we can set them up the same way, right? We can set them up the same way where it's going to be so sine inverse of our ratio 8 over 17. Sine of 8 over 17 is Now, again, depending on your calculator, it might round it a little bit nicer. Right? What'd you get, Matt? You got the same answer? Okay. It might round it depending on what your calculator does. My calculators gave me that, so that's what I'm using. Does it help out? Is it pretty easy? Yeah. Okay. The last thing that we can talk about as well is actually solving for the length of BC. If I'm given two side lengths for these, I'm going to draw this out one more time. This is 17. This is 8. Okay. A, C, and B. You can use any of the trig ratios to solve this out. Doesn't matter which one you use. The other thing that you can do is we can actually use Pythagorean Theorem. Let's call this side 7, or Z. For solving for Z, okay, what's the Pythagorean Theorem? Leg 1 squared plus leg 2 squared is equal to the hypotenuse squared. So this would be 8 squared plus b squared, or z squared in this case. Let's put it z so we can put it in context. Is equal to 17 squared. We're going to get 64 plus z squared. I believe it's 289. And then you're going to get z squared is equal to, I believe it's 225. Z is equal to 15. So I would definitely just do it that way instead of using the trig that can mess you up. You can also use a trig because now you know the angles. If you know an angle on at least one side, you can use sine, cosine, or I think you can use tangent. Yeah, you can use either sine, cosine, or tangent to solve those out. This is probably the easiest way to do it. Cool story? Yes?
Can you remind me how to simplify from z squared?
Z squared is equal to 225 right here, right?
Yeah.
Is that where you're getting mixed up? We take the square root to both sides now. Right, z is equal to 15. Square root of 225 is 15. So you'll be able to do it. It's not going to be too. Yeah. Got to be able to take the square root. Questions? Flip it over to the back side. 7 is very similar to 5. I'm going to flip it over to the back side. 8 or 9? Which one? No. Lord. So try to draw this. I heard 9 first, so I'm going to do 9. If I have time, I'll come back to it. That is my accurate depiction of our picture. I'm going to show all parts of this Uno problem. This Mano problem. Ew. Ah. Here we go. Are you guys ready for tomorrow's PSAT?
No.
Woo!
Yay.
Yeah, you're gonna be. I don't even know what we're doing. I don't know if I have to be up there. We'll be here. I don't know what we're doing. Whatever. Hopefully, I can be here. Here we go. Noah. Okay. You gonna pay $60? Oh, whack attack. You need to be in like pre-cap. You're a smart kid. Staying home? Don't stay home. Using my triangle here, I've got to be able to set my ratios correctly. One thing we know about the triangles of this property tells me that the short sides are b, the long side is b radical 2. So what I want to be able to do with those is set those equal. I know that 10 is going to be my hypotenuse, so this is actually equal to b radical 2. The shorter sides is b and b here. So once I figure out what b is, I can plug it in to get my 30, 60, 91. Now, next to them, I'm going to write them all separately. 10 is equal to b radical 2. Then I have b here and another b there, because I need to be able to plug those in. Essentially, what we get here is we want to be able to solve out the one with the variable. So we're going to divide both sides by square root of 2. This is why this is going to give us, a lot of you guys gave me this for an answer, which is technically not correct. This is just a part of it. Because I can plug them into these portions, I know that my b right here on my lower side is going to be 10 over radical 2. Now, I do not, this is technically a wrong problem because we cannot have radicals in the denominator. I never showed you guys how to do that, so just keep it like that. That is fine. Now, in order for us to fill this out, to finish this out, we've got to be able to do the 30, 60, 90 triangle here. The bottom of the short side is b. The hypotenuse will always be 2b. That means the medium side is b radical 3. We've got to be able to correctly label the 30, 60, 90 triangle on this one. So if I get this one, my hypotenuse will be 2b. That means x is going to be equal to b radical 3. That means 10 is going to be equal to b. If we set them up down below, I'm going to get b radical 3 is equal to x. I'm going to get 10 over radical 2 is equal to b. And 2b is just there. There's nothing really we need to do with that. Okay? The hypotenuse is what we don't need to solve out for. What we do need to do is plug in our b term into this other equation. So when we do that, we're going to get 10 over 2 times radical 3. Again, we can't simplify anything out because they're not like radicals. So 10 radical 3 over radical 2. This is our answer. I'm going to check the problem to make sure that it's going to be a good one, because I want you guys to get, I don't want you guys to freak out and do this and go, I did something wrong. So I want it to be nice. That's why number 8 was very, very appealing, because it came out to a nice value, because when you divide it out by radical 2, it gives you 4. Sorry, yawned, you yawned. The contagious yawn happens. Your eyes get watery. Okay? Yes? Do you want me to do 10? 10? No? Yeah? No? Let's do 10. I'll do it quick. 10 is talking about a ladder. This is my building. Let's say this is my building here. This is my home. It's my window. What Mr. Aguilar is doing is putting a ladder against the wall. The ladder itself is 8 feet tall, so leaning against it still 8 feet. The distance from the floor to the ladder is 5.5. We know it forms a, this is number 10, yes. So this is our triangle we want to use. So if I use that, I don't need anything else. Bye, home. The winds are blowing it away. That's a triangle we want to be able to identify. It asks us, find the height of the building round to the nearest tenth. We can find the height of the building here. Then it says, find the angle in which the ladder makes with the ground. So in this case, the ground to ladder is our angle. Let's label that X. X, man. What I would do first is do the Pythagorean Theorem to solve for the height of the building. In this case, a squared plus b squared equals to c squared. Short side of length will be 5.5 squared plus h squared is what we're solving out for. And h squared, which is 64. 5.5 squared is 30.25 equals h squared. 64 for square root. 64 minus our answer. We're going to get a nice h squared is equal to 33.75. To find what h is, what do we have to do? Square root both sides. We're going to get h is equal to square root. The root is getting squared. That's where I got my answer, 5.8. Which makes sense. If the ladder is up against it with no degrees, it's going to be 8 feet tall. But if we pull back the ladder a little bit, the height of the ladder is going to fall a little bit. So it should be less than 8. Right? Should kind of make sense. Hopefully. Should. OSHA has regulations on that about how many degrees you can loft over. Just saying. For this case as well, we're going to be able to find out for x because I can do, in this case, I know it to be my opposite. So cosine of my angle is going to be 5.5, which is adjacent over hypotenuse, which is 8. So that's going to be 46.56 degrees. Okay, again, this is going to be my adjacent to that angle. This will be my hypotenuse. The h on this one is just the height, so we don't have any information. So Sohcahtoa, we don't have anything on our opposites. So and ka or toa go away, leaving us cosine. So I use cosine to find my ratio. I want to be able to do. 11. Are we okay? You okay? Easy? Easy? I will do that one first tomorrow just to get out of the way so you get points. Number 12 and 13? Questions once? 12? Here we go. This is 30, 60, 90 triangles, so we have to use our triangle lengths. In this case, if I gave you one that's upright, this would be, shortest side would be B, longest side would be 2B, back side would be B radical 3. So we got to be able to label all of our parts of this. That means 5 over 2, which is the shortest side, will be B. That means X will be 2B. That means our Y will be B radical 3. What do I do with these? I take these and do what? Write them down below. B is equal to 5 over 2. Then we get Y is equal to B radical 3. That means we get X is equal to 2B. Which one am I going to use? 1, 2, or 3?
3.
3. 1. We're going to plug it into 1. Y is going to be equal to 5 over 2 times radical 3. That's why this one is that answer. If we plug it into our last, X is going to be equal to 2 times 5 over 2. What happened to those 2's?
They come together.
This is why this one is 5. Done. That's it. Well, some of you guys are packed up. I don't know why some of you guys are packed up. You want to get out of here. These guys like hate my class. Oh my God. Oh my. Questions?
Did you get that done?
I didn't yet. I talked to my wife. She's like super down with it, but it's a little bit expensive. A little bit expensive. Yo! I believe you'll only go to your 5th and 6th period tomorrow.